Before we look at the branches of physics, let's begin by looking at the goal of physics in life. So what is the goal of physics? The goal of physics is to use a small number of basic concepts, equations, and assumptions to describe the physical world around us. I can just begin by asking a simple question that what is speed, for example, and here I know that you'll tell me that speed is the ratio of distance to time. In other words, speed is equal to distance out of time. That is a concept. Speed is a distance out of time, and the equation of that concept there is this one here, that speed is equal to distance over time. Now, using this concept and the equation plus the assumptions, you can always describe the physical world around us. For example, you can be given a task of designing maybe toy cars. Someone may design a toy car like this, another may design a toy car like this, and in case both of these toy cars have been given an equal force to push them, we find that this one may cover a smaller distance, this one may cover a smaller distance, and then car B may cover a longer distance, yet they have been given an equal push. Now you may ask yourself that what could be the problem? What causes this? Or how come that someone has come up with this? Of course, someone has assumed that if maybe there is air resistance, if you design a toy car in form of B, it will cover a longer distance because it has minimized on the air resistance. That could be an assumption, and that is what the goal of physics is all about. Use concepts, equations, and assumptions to describe the world around us, to make a better world around us. Now, these physical principles, concepts, equations, and assumptions together can be used to make predictions about a broad range of phenomena. For example, why are racing cars designed in such a way that they are shorter and they are streamlined? Streamlined means that they are pointed at the front, and then shorter, they are nearer the ground. Why are they like this? So someone who came up with this idea, of course, predicted, used the assumptions which were later verified. For example, a center of gravity. In case a body is to be stable on the ground, it has to be shorter. Its center of gravity has to be nearer the ground. In case this car is to move faster, then it must look for ways of minimizing the resistances to motion. For example, air resistance. So made this one pointed. So in so doing, even we see that all vehicles are all pointed. Of course, someone began by looking at very many objects. For example, a bird, for example, the fish. They are all streamlined, they're all pointed in the front. Why? The reason was to reduce on the air resistance. So that's why this one has been done in the same way. Likewise, physics discoveries often turn out to have unexpected practical applications and advances in physics, which in turn lead to new physics discoveries. I've just talked about the center of gravity. Where did this one come from? Of course, it all began from one scientist called Sir Isaac Newton, who was sitting under an apple tree doing his mathematical work. In the process of doing his work, an apple fell on his head, and then because he was perturbed, he asked himself questions. Why is it that this apple is falling onto me? Why isn't it just moving upwards? In case we have a downpour, rainfall, why is it that the rain droplets simply fall down? Why don't they simply move in the opposite direction and then they move upwards? So he came up with a concept called gravity, the idea of gravity. That's where it came from. So from that observation that he made, and since he documented it down, he wrote it down, other scientists who came up later after him came up with what we call the center of gravity. For example, how does it affect stability? The shorter an object, the more stable it is on the ground. The wider an object, the more stable it is on the ground. So all those concepts, those simple concepts, are developed later on to come up with new discoveries. And that is what physics is all about. Now let's go to the branches of physics. The branches of physics basically are listed down here, and I can just let you know about each of them. For example, we have a branch called mechanics, we have a branch called heat, light, electricity, magnetism, wave motion, and modern physics. And for us, we shall also add on another one called the space physics. Space physics. I may call it a branch, but this one deals with heavenly bodies, the Earth, planets, Earth, Mars, Jupiter, the universe, galaxies, and very many others. So each of these ones here, we've tried to explain each of them. That, for example, mechanics, which comes from, for example, machines, and this is all about topics like motion of bodies, forces acting on bodies, among others. Heat, you know what this one is all about. In case you have to cook food, you need heat as a form of energy. Plus, of course, we shall be looking at other forms of energy. How are they transmitted, the applications, and so on. When we talk about light, this is very important. Assuming that you are blind, what can you do? In other words, in order for us to see objects, we need the presence of light. So we shall be looking at the nature of light, its properties, how it travels, and the applications. Then we have electricity. Imagine a world without electricity. You can answer yourself about this. So under electricity, we shall be looking at how electricity is generated, how is it transmitted, and the applications as well. Then magnetism. This deals with the properties of magnets. I know you have looked at magnets in your primary science. How are they produced, their properties and applications. Wave motion. I'm talking to you right now. So, how is it that I'm able to speak to you? That brings in the idea of waves. So, under wave motion, we shall be looking at how energy is transmitted from one point to another without the movement of the material medium itself. An example here is waves on oceans, the tides. For example, in case of playing a guitar, you simply pluck the string and then it moves. It is producing sound. The speaker in your earpieces, the laptop speaker, it produces sound in form of waves. We shall be looking at that. Then we have modern physics, radioactivity, the X-rays, all those ones are under modern physics. And then lastly, I've also talked about space physics. So all those ones simply describe the branches of physics. To talk more about the branches of physics, let me just use these illustrations, these images, to describe what each of them is all about. For example, can you guess what this one is about? This is an amusement park where people have gone to enjoy themselves. And this is all about mechanics. So you can see how mechanics is applied in real life. Under mechanics, of course, we have motion, we have forces acting on bodies to create motion, we have what we call Newton's laws, energy, momentum, work, energy, and power. All of those shall be looking at them as we go along the way. Then we have this picture here. What is this picture? Can you guess what it is all about? Okay, this is a negative of an image that was taken. Maybe someone has taken a photo and this is what its negative looks like, and that is a postcard. So how is it able that an image can be printed onto a paper, like photos that you take maybe during picnics and so on? It is all about electricity, electrostatics. Shall be looking at this and very many other applications. Then magnetism. Of course, this is a cartoon, and we have this person here. The person is asking this dog, has someone eaten all the refrigerator magnets again? So he's asking the dog. Of course, this is just a simulation, just to show what magnets can do. When you have a magnet and a metal and then bring all the two together to each other, they'll be attracting each other. So you shall be seeing applications of magnets. First of all, how a magnet is produced, their properties, the applications, all that will be under magnetism. Then we have waves. We've talked about waves. In this case, we're having a spring like this one here, and these kids are looking at it, the waves. Vibrational motion, stretched strings, sound waves, electromagnetic waves, all that is under waves. Then we have optics, all about light. We know that white light has 7 colors. For example, colors seen of the colors of the rainbow. What are the applications of light? We shall be looking at the nature of light, properties of light, how is light produced, what are the applications of light. Under this, we shall be looking at reflection, refraction, lenses, mirrors, and very many other concepts, ideas. Then we have thermodynamics. This is all about heat. For example, we have this diagram here. Can you guess what this diagram is all about? These are balloons used by tourists. How are they able to move up? We shall be looking at this. And of course, under heat, we shall be looking at heat transfer, temperature change, the gas laws, and very many other things. Then we have modern physics. I've talked about this. Remember about the X-rays, the cathode ray tubes. How is your TV able to work? For example, TV set. The scans. In case you go to the hospital and then they scan your body, in case you're a pregnant wife, you're a pregnant woman, they scan your body to see what is inside there. How is the baby moving? In case you had an accident and they scan you to see the fractured, the broken bones. All that is under modern physics. Radioactivity, the atomic bombs, the nuclear energy, production of electricity using nuclear energy. All that is under modern physics. So you'll be seeing all of this. So among the applications of the branches of physics, let's look at this picture here. We have the car headlamps, the side mirrors. Where do these ones fall? Applications of branches. That is under light, optics. We have spinning wheel of vehicles. In order for the car to move properly, in case it is to move without sliding, without having any hindrances, that is under mechanics. If the car falls onto a hump on the road, it falls into the ditch of the road, on the road, and then as a result, it moves up and down. It vibrates up and down. In other words, you talk about the springs, the shock absorbers. All that is under waves. Then we talk about a battery starting a car, that is ignition. That is under electromagnetism. This is a combination of both magnetism and electricity. Then when you touch this part of the car here, maybe the engine of the car is feeling hot. What is it all about? That is under heat, thermodynamics. So what do we have to do in order to make the car not to be heated up so fast? We use what we call the coolants. So we shall be seeing all of these applications as we move along the way. Let me also give you an exercise. I've got pictures below here, so I need to identify the branches of physics and how they're applied. Experiment is happening in each picture, so you can pause the video and look at the first picture here. Write about it. What are some of the branches of physics and how are they applied in this picture here? We have picture number 2. Someone is frying a Rolex. Feel like eating one. Then we have another picture here. This is a circuit board in your radio, TV set, phone. So pause the video and write about each of those pictures there. Okay, welcome back. Let's begin from the first picture. In the first picture, we have this dynamo here. What do you think dynamos do? They produce electricity to provide light at night as you're moving. So in this case here, we shall be talking about, for example, electricity. Then we have this bicycle tire. We have this bicycle tire here. What does it do? It is moving. So we have a branch called mechanics. So you can think about that. Then in this picture number 2, of course, someone is frying with the heat. So we have a branch called heat or thermodynamics. In this case, it enables someone to cook food, and in so doing, the person is trying to position his hand in such a way that it is not overheated, my baby, by radiation. That is now heat transfer. How is this egg or the chapati able to get the heat from the burning charcoal? How is it transmitted? That is under conduction, radiation, convection. We're looking at all those forms of heat transfer. So that is under heat. Then picture number 3, someone is operating a computer, the CPU of the computer. But still, this one be a mechanic operating a radio, a TV set, your mobile phone, the laptop, the tablet, any electrical device. So under this diagram here, you can see someone trying to use a branch of physics called electricity. So those are some of the applications of the branches of physics. Thanks for trying out. Remember to like and share our YouTube channel, Facebook channel, as we discuss more things there. Thank you. See you in the next lesson.